So when you're factoring by looking at the structure of an expression, sometimes you'll run into some more complicated examples that look like this. So let's simplify it and look at a regular quadratic that we know how to factor, where we just ask ourselves what adds to that middle number and multiplies to the last number. So if you think about factors of 24, negative and 6 and positive 4 happen to be the winning match in this case. So it would factor into u minus 6 times u plus 4. And I just picked a variable here. You could use x, you could use y. Let's try to apply that to this bottom example. This is something squared minus 2 times that same something minus 24. So if you're looking here, it looks to me like this actually does follow the same structure as that quadratic we have up there. So I'm going to help myself out a little bit, and I'm going to substitute in something for those two expressions. So let's say let u equal x squared plus 5x. That way I'm able to rewrite this expression as u squared minus 2 times u minus 24. Okay, well, I already know how to factor this. We did that up there. It factors into u minus 6 times u plus 4. But remember, they didn't give us u to start off with. They gave us x squared plus 5x. So now that I've factored it, I'm going to substitute that x squared plus 5x back into it. So instead of u, I've remembered that I let u be equal to x squared plus 5x when I started. So now I'm looking at what I have here, and I'm noticing that I have just two regular trinomials with a leading coefficient of 1. So if I'm factoring, yes, I've factored once, but I always want to try to factor completely. So I'm going to ask myself what adds to 5 and multiplies to negative 6. So in this case, I could factor this first trinomial into x plus 6 and x minus 1, because 6 times negative 1 is negative 6, and they add to positive 5. If I'm looking at my second trinomial, I could ask myself those same questions. What adds to 5 and multiplies to 4 to get x plus 4 times x plus 1. So this would be the fully factored form of what we started with up there. So the hardest part about these problems is recognizing that it looks like a quadratic or a regular trinomial that we know how to factor. So make a substitution. Now I picked u as my variable, but again, you could pick anything you want as long as it's not x, because they already used that. And I substituted it in so that I knew how to factor it like a regular trinomial. And then from there, I plugged back in my value for u, and I factored some more. So generally, once you factor once for these, you'll have to factor these trinomials one more time. Let's take a look at one of the trickiest examples that I could think of for these structure problems. So I'm going to use that same trick as before, because it looks like I've got something squared minus 4 times that same something. So I'm going to say let u be equal to 6x squared plus 7x, and I'm going to make that substitution. So now I have u squared minus 4 times u minus 5. And I can factor this by asking myself what adds to negative 4 and multiplies to negative 5. So those two numbers are going to be negative 5 and positive 1. And if you're not sure, you could try a couple different numbers in your calculator. And now I'm going to substitute that 6x squared plus 7x back in for u. So I have 6x squared plus 7x minus 5 times 6x squared plus 7x plus 1. So now I'm going to look at both sets of parentheses and try to factor again. The problem here is that I now have a leading coefficient other than 1 for both of these trinomials. So rather than just using that regular AM method, I'm going to need to use the AC method, where I multiply the first and the last number, and I try to find numbers that multiply to -30 that add to that middle term 7x, so that I could split it and then do factor by grouping. So some numbers that multiply to -30, I'm thinking 6 and 5 probably won't get me to 7. 15 and 2 won't get me there either. So sometimes if you have something like -30 that has a few factors, just checking in your calculator might be the fastest method. But if I'm looking at 10 and 3, I notice that if I multiply 10 and -3, I get -30, but they add to 7. So I'm going to rewrite this first trinomial as 4 terms. I'm going to split that 7x into -3x plus 10x minus 5. And now it doesn't matter if you put the 3 or the 10 first, it'll still work out. And then I could factor that by grouping. I can group the first two terms, pull out a GCF of, let's say, 3x there, to be left with 2x minus 1. And for those second two, I could pull out, let's say, a positive 5, so that I'm left with the same thing in the parentheses, 2x minus 1. So I could take out the 2x minus 1 from both of them, and rewrite my leftovers, 3x plus 5. Now, I would hope that you see why I said this was a difficult problem, because we're not even done yet. We factored that first trinomial that we were left with, but we still have to do the AC method one more time for that second trinomial. Multiply 6 and 1 to get 6, and ask yourself what two numbers can multiply to 6 to get positive 7. This one's a little easier since it breaks down into just 6 and 1. So I'm going to rewrite that polynomial as 6x squared plus 6x plus 1x plus 1. So now that I've used that AC method, it just becomes a factor by grouping problem. I'm going to look at 6x squared and 6x, and notice that I could pull out a GCF of 6x from there to be left with x plus 1. And from 1x and 1, I can only factor out a 1, so I'm going to do that so that I'm left with x plus 1. Again, notice that it's the same thing in the parentheses. Every time you do factor by grouping, it should be the same thing. So you're just left with x plus 1 times your leftovers of 6x plus 1. So your final answer here is 2x minus 1 times 3x plus 5 times x plus 1 times 6x plus 1. I double checked just to make sure there's no GCF I could pull out. So what we started with all the way up here, once we did this u substitution, I factored it like a regular trinomial. Then I substituted that u value back in, and I had to use the AC method on both of these trinomials because they had a leading coefficient that wasn't 1. So in the last example, it was a little bit easier because we could factor it like a trinomial, but these are going to be the longest examples. There's lots of places to go wrong, so make sure you're careful with your work.